idea behind AI is by looking at all the data, you're going to be able to understand what's going to happen, right? By looking at everything from the past, you can understand what's going to happen. And the first thing I want to share with you, and that was the objective of using this example, is that you can understand that in a lot of cases, this doesn't work, right? Because what is in the future sometimes never happened in the past. And if you want to be able to forecast, if you want to be able to to make a decision, you need more than just knowing all the data from the past. However, what happens today with AI of today, and of course, Julia explained that very well, at least what is done with the neural networks is really based on data, and is based on data from the past, because until anything else happening, and I'm going to talk about that, we only have data coming from the past. So the first thing I want to share with you is, well, there are limits that comes from the fact that AI today, I would say neural networks, only use data from the past, and that's a big limit of what you can predict with this data and what you can anticipate with this data. So just an example, and if I take a step back and I go to see what was AI, we have had different definitions of AI. I will give another one at a different description level. AI originally was made to try to mimic our brain. And our brain, roughly speaking, is able to do two kinds of things. The first kind of thing is recognize. If I see someone here in this room, I'm able to recognize this person tomorrow in a crowd. By the way, we were talking about black box. It's a real black box, the way it works, because I'm absolutely not able to explain to someone who is not here today how to recognize the person tomorrow in the crowd. And, however, I'm able to do it myself, right? So this is the recognition part of my brain. But hopefully, my brain and your brain, they have another ability, and the ability is to reason, the ability to understand, the ability to model, to make links between things, and to infer, to forecast. This is another ability of our brain. And when we think, when we solve problems, when we find solutions, we use both of them. Now, when I'm speaking, you use both parts, I hope. One is you recognize my voice, you recognize the words I'm saying, and you recognize all that. This is the part that is able to recognize, and it goes very fast. And the other one, you recognize the meaning of what I say. You make links between the models of the world you have in your brain, and you're able to anticipate. Maybe you say, oh, I know where he's going, or I think he's going to say that, or I disagree. Right? And you're using both sides, and I continue to speak, and so you continue to use the recognition part, and it goes that way, right? So there are one good news, one bad news. Let's start by the good news. The good news is we are able to create machines which are able to learn how to recognize. This is what we do when we create neural networks. We teach a machine how to automatically recognize. It's not perfect, as the previous speaker said, there are limits to that, but it's more or less okay. We are able to teach a machine how to do that. The bad news is we are not able to create a machine that is able to learn how to reason, how to understand. This is the second part, right? And this, we are not able to do it. And all the examples that have been given before go in this direction. If you look, for example, at the AlphaGo, which won in the game of Go against the best human. By the way, we don't know if AlphaGo plays well. The only thing we know is AlphaGo is better than the best human. But we don't know if the best human plays well because we don't have any comparison. The only thing we know is he is the best human. So AlphaGo is better than the best human. And it's mainly done, not only, but mainly done by recognition algorithms. So when you use AlphaGo, AlphaGo has learned how to recognize a position that is going to lead at the end of the day to a win. So AlphaGo is going to choose this solution amongst all the possibilities that it has, and so on and so forth. The consequence of that is that if you take AlphaGo that has been trained on a 19 by 19 board, and you want to use AlphaGo on a 15 by 15 board, it plays very badly. Because, you know, it's not what he has learned. The images that win, the patterns that win are not the same. The difference with a Go player, is I have absolutely no doubt that the world champion of Go, if I play against him in a 15 by 15, I'm going to lose, even if the rules are not exactly the same. Right? So all these tools that you see, all the things that you listen about, artificial intelligence today, I mean almost everything, not everything, but almost everything is about recognition. Well, why has it been so successful? It has been so successful because in some cases, the only thing that you have are data. And you want to learn, but you don't have anything else. And this is the case, for example, in a lot of B2C businesses. When you work in a B2C business, you're Amazon, and you have these people buying your products, and you want to know what to recommend to someone. You don't know anything about people. You don't know why. You don't know the meaning. You don't know the reason why they make their choice. You don't know anything. So the only thing you can is look at all the data you have from the past, try to find relations between these different parts, these different people, or the people who bought that, they also bought that, and you use a very, very, very sophisticated algorithm to find these correlations. And then you're able to make recommendations, to people and to sell more and sell more and sell more. You're in a situation in which you don't have a lot of information about causalities, about the reasons why. You don't really need why things happen. You don't really need understanding. The thing you need is try to find correlations, and it happens that it works quite well. Not 100% well. For example, it recently happened to me that I wanted to buy candles for birthday on Amazon. I didn't, at the end of the day, I made a search, but I didn't buy it. But during 3 months, it was every time I was going to a website, I had some offers about candles, because the machine didn't know anything about the reason why I wanted to buy candles for a birthday, right? Is that there is a birthday, and the birthday is at a specific date, and 3 months later, I don't need them, right? But this is how it works. So for a lot of situations, this is quite good. It means that data is efficient, meaning in a way, data can be enough, or at least you don't have anything else, then you use data. And a lot of software, a lot of solutions that have been developed in this context. The problem is that this has limits, right? The first limit is that there are a lot of things you want to be able to predict that you cannot find in data from the past. Just, for example, because it never happened in the past. So if you're an industry and you want to be able to forecast unexpected events, well, if they never happened in the past, you will never find them in data, and so you will have a problem. The other problem of this approach is that you're just looking at correlation, and correlation makes that it's a black box. There was a very interesting remark from Luc Julia that said, it's not theoretically, it's not a black box because there is a mathematical function, and you can rebuild the mathematical function. So in a way, it's explainable, but it's not explainable the way you want it to be explainable. When you say, I want the algorithm that recognizes a cat to be explainable, it means I want to know why the algorithm says that it's a cat so that I can reuse it somewhere. And this is not the case. You just have the box and you just can use it. At the end of the day, you can find the mathematics behind, but that's not what you're looking for when you're talking about explainability. So you have a lot of limits of this kind of AI. But the biggest limit is what I said before, is we are not able to create a machine that learns how to reason, how to think, meaning we are not able to create a machine that from itself is able to create causalities. Explainability is causalities. I can explain by a chain of cause and effects that this is going to happen. This is causality. As I said, the bad news is it's not possible to do so automatically, to create a machine that learns how to do that. This was the bad news. The good news is that machines, which for reasons we don't really know, have been able to do that in the past and are able to do that now, are humans. We have been able to learn how to reason. We don't really know how, and we don't really know why, but we have this ability to create causalities, to know causalities. So one solution, if we want to build machines which are able to augment our intelligence, is to use what we are able to do, is to use these causality models that we have created ourselves and to put it in software and to make links maybe with more classical artificial intelligence based on neural networks, and put everything together and use it to be able to forecast things. If you go back to the car example, you cannot just use the rear view mirrors. You can have the light that shows you what the future can be, and then you can make your decision based on this forecast. And why is it so important? As I said before, in some cases like retail or social networks, you don't really need a structure. You don't really need to understand causalities. What you have, data correlation is enough to create a lot of value. But there are other domains in which you really need to understand, what the future will be, and this happens in a very, very structured situation. And this is what happened, for example, in the industry. In an industrial system, if you want to forecast the system, if you want to know what's going to happen, you cannot just rely on what happened in the past. And just trying to rely on correlations, just trying to rely on data from the past, will be not only not very efficient, but it would not be very smart. Because you have a lot of knowledge about the system you consider. You have a lot of experts who know a lot about different parts of the system. They have their own intelligence that allows them to understand part of the system and the way the part of the system is behaving. And you have a lot of experts. So, of course, if you want to be able to go further, to augment their specific intelligence, you want to do it, but you want to use what they have in their brain. You want to use the knowledge they have in their brain. And that's why in this domain, and this is what is happening in industry, just using data from the past is not only not enough, but it's absurd, because you have much more than the data from the past to use. You have knowledge, you have causes and effects that you know for your, the different pieces of your system. And this is what we call, and this is not so far from what Luc Julia called also augmented intelligence, which is to say, it's great to have these neural networks. It's really fantastic. And for some parts of your system, you can use neural networks to learn things, for example, that experts don't know. And you can do that. But for other parts of your system, you have experts who are very, completely able to explain and to describe how things are happening, what are the links, cause and effects links. And you have different experts being able to do that. So you would say to me, why do I need, AI or augmented intelligence if I have that? Well, because no expert knows everything. Experts only have a piece of the knowledge. And what you need to, to answer your problem, and I will give you one or two examples, is you need to have a global perspective to be able to know what is happening when everything happens together, right? That's what you need. You need to know when the system is complex, what the behavior of the system will be. Or you want to know, what if I do this? Or what if I do that? Am I able to, to forecast, to anticipate, to make better decisions? And this, you cannot do it, and it would be, in a way, not very smart to do it only with data from the past. You really need to build on intelligence. Let me give you one or two examples. If you consider a manufacturing company, for example, creating cars, you build engines. This company can build a lot of different engines. There are a lot of factories building the different engines. And each factory has a lot of machines taking pieces, transforming them, putting them together, and so on and so forth. Each machine can do a lot of different things. And pieces are going from one factory to another one. And at the same time, there is the demand. For the next 52 weeks, you need to know, you need to be able to produce this number of this engine, this number of this engine, this number of this engine, and this every week. And you want to know what is the best way of doing that. And what if you decide to change, or what if you decide to change a machine in a factory? If you want to do that, you have in your company all the knowledge about the different machines, what they do, different factories, when they're available, when are people working, when they're on vacation, you have everything. But if you want to find the best solution, you need something that is much smarter than each of you. You need something that is able to aggregate all this intelligence, and that's what we are Loic was talking before. You need to have kind of a digital twin, and you want to use the digital twin to, run different simulations. In a way, you augment the intelligence of all the different shareholders, the different experts. And in some cases, you're going to use specific representation of part of the system which do not come from the brain of some experts, but because there is no expertise explaining what's happening, but you're going to use part of the system that has been modeled with an AI tool. For example, if you want, today that AI and neural networks are used for predictive maintenance, taking one machine and saying, okay, this machine, based on all the data, we know that in 3 months, within the period of 3 months, we have to maintain it, otherwise it will fail. And you can have this information, not from the brain of people, but from data from the past. And what you need is to be able to put all that together, the intelligence of the different experts, you link it, intelligence of machine learning algorithms, you put it together, and then you're able to augment the intelligence of all that by being able to look into the future. And then I come back to what I said before. I don't think we have to oppose machine learning or data-based machine learning algorithms on the one hand, and causality or knowledge-based artificial, modeling algorithms on the other, and saying that one is better than the other. My deep conviction is that the future is in mixing them, in putting at the same time the intelligence coming from machines that is quite advanced in some situations, in particular when we are able to recognize and when what we need is recognizing, and causalities coming from the brain of experts, causalities coming from the brain of people. And when you put that together, you can create simulations, you can run simulations. And what I find very funny to say is, well, we don't need data from the past. What we really need are data from the future. Right? Assume that I'm able to give you data from the future. Oh, you would be very, very happy. I'm sure you're going to play lottery just after going outside. But if I would be able to give you that for your business, you would make great decisions based on that. So the idea is to be able not to give you the real data from the future, but a flavor of what the future can be, what the future can be when you do this, what the future can be when you do that. And that's exactly what augmented intelligence is. It's using, on the one hand, artificial intelligence, on the other hand, human intelligence, putting it together, and for situations where causalities are important, where there is a lot of structure, not the same as Amazon or Facebook, when you really have a lot of structure, which is the case in the industry, use this, put it together to augment our intelligence. And at the end of the day, there are two things that you can do. The first, that you can realize. The first one is you're going to provide a lot of data, and you can analyze this data using artificial intelligence tools, because it's very, very big, and you may need to find structure inside that experts don't know. This is the first one. The second one is that you can see the human being is always at the center. So you're going to have this, it will be transparent, it will not be black box, and experts will be at the center to use the tool. So it's really some mix between machine intelligence and human intelligence, and I really believe this is the future. Thank you.